So, thank you all for coming and hearing this exposition. Let me ask you, I mean, rhetorically, when do you see the beginning of artificial intelligence? Most people put it 1956 Dartmouth, but the reality is that it started way before that. It started at the Department of Philosophy at the University of Chicago in 1943, or even sooner, since this is the year when the paper was published. The paper was from Walter Pitts and Warren McCulloch about the artificial neural networks. And here you can see the drawing of the initial neural networks, the first one in history, how they were sketched. Of course, this is Walter Pitts, this is Warren McCulloch, and the third person is Letvin, who was a co-author on a number of papers with them. The whole idea which they wanted to put forth was a different mode of computing. And what is interesting that at this point, you had, let's say, regular computers as such. But you also had something that was different. And that thing that was different was a room like this one, full of cables, and full of those switches which, you can turn it, you can dim the lights, those kind of switches. And in these beginnings, it seemed like there were two different styles of computing available. And cybernetics was interested in the kind with the dimmers and not with the kind with the 0 and 1s. So cybernetics as such were born under that name in 1948 at the Department of Mathematics at MIT. The person responsible for that was Norbert Wiener, who by education was also a philosopher and logician, but his main work was in mathematics, and he's considered the father of cybernetics. The interesting part here is that he thought of cybernetics as a new science that should make not analogies between man and machine, animal, society, and so on, but discover and research all those processes which are the same. For example, you have evolution. There was, I don't know whether you heard this, I recently heard about it. There was an experiment, an interesting experiment in the 90s, where they had a group of chimpanzees, I suppose, or bonobo or something like that, and they gave them toys. They gave them dolls, and they gave them trucks. And of course, I don't even know what was the main purpose of the experiment, but the interesting part was that the girls choose mostly dolls, and this had some explanations lying around. But what was puzzling is that the boy chimpanzees choose trucks. But I mean, they don't know what the trucks are. So they develop an elaborate, let's call it neo-cybernetic explanation that actually toys underwent evolution, but evolution as such, so that they can relate to stuff that is unconsciously present in the primate mind and not necessary for any primate, human or bonobo, chimpanzee or whatever, to be able to understand the concepts behind the toy truck, but that they were attracted by it by something more deeper inside. This was one of the most interesting parts where you can actually see a cybernetic theory at work, because evolution as such was an evolution of toys, something that usually does not evolve. But when you think about it, it can follow the same rules as normal Darwinian evolution. And this is what cybernetics was supposed to be all along. But there was another thing that was coming around, and it was coming around in 1953 in the Soviet Union. So you perhaps know that this was the year when Stalin died, and this happened shortly before that, but it was quite an interesting story. So cybernetics was alive and well for 5 years. The Soviets were also interested in cybernetics. We're interested in the technical aspects of it. We're interested in systems that can handle feedback and so on. But then came a paper in a philosophical journal, Вопрос философии, and the paper was titled, the author was someone called Materialist, and the title was of the paper, Whom Does Cybernetics Serve? The point was that he, let's say, demonstrated that cybernetics as such is something that is wholly incompatible with Marxism. And as such, the next 7 years, there was no research in cybernetics in the Soviet Union. Nothing was touched. People were afraid. Stalin died, but people feared. The fear lived on. And what is interesting here, and now let me depart for a moment from history and step into conspiracy theory. Imagine that this paper was actually written by a US intelligence agency. It would be brilliant. You stop the development of a competing superpower for 7 years, technological development, with a philosophical paper. I mean, it is nonsense, but you can see how this could be something behind it. I repeat, this is not actually verified or a piece of history. This is just an interesting conspiracy theory that departs from the historical part. The historical part was that actually people were afraid that cybernetics did not catch on. And at this point, cybernetics was mainly focused still about artificial neural networks. The basic ones from Pitts and McCullough from 1943, and some applications of it. This is important because actually at this point, there were things that regular computers could not handle even remotely. One of those things was processing images. The other thing, which was very interesting, was actually something that started back in the US in 1954, and this was machine translation, also at the University of Chicago by Jehoshua Bar Hillel, who later worked in Israel. And the idea was that you wanted a machine to translate a large number of Russian texts, and the Russians wanted to translate a large number of English texts. And this had the projects dealing with this brought in a lot of financing, mainly from the US Army or the Soviet Army, and were kind of interesting. But bear in mind that in the US, cybernetics was alive and well in this period. In the Soviet Union, it was really dangerous to speak about anything that had to do with cybernetics. In the Soviet Union, machine translation started in 1956, 1957 by the work of Lев Andreev and Kulagina, it was Leningrad and Moscow, respectively. And the systems that they had in place were something that you probably would all think like a first idea when doing machine translation. Make a big dictionary and simply recombine it with a dictionary. When a word has different meanings, then calculate which meaning is taken more frequency. For example, if you have, in Croatian, you don't have different words for time and weather, it's all vrijeme. But for example, you can say that in 30% of the time, vrijeme means weather, and in 70% it means time. And so you simply use this kind of sampling. This was the idea behind Lев Andreev's prototype, and to a point behind Bar Hillel's more advanced prototypes, since his original prototypes were really, really simple. It was the beginnings. So now, only now do we come at what is usually considered the birth of artificial intelligence. And this was the Dartmouth Conference. The Dartmouth Conference, as you probably all know, had, among others, these people who are perhaps the most interesting and most important participants in the Dartmouth Summer Project, out of whom perhaps Claude Shannon is the person who is the least known of the most important people, and he actually is the person behind a lot of things that we use today in artificial neural networks and, by extension, large language models, and by extension, transformer architectures. But it's not that much interesting in our context. What is interesting is when we come at 1957 to 1959 at the University of Zagreb. And we have this man. His name was Bučo Laszlo. If you Google him, you'll notice that he's mainly revered as a linguist and not as a pioneer of computer science. But what's interesting is this paper of his from 1959. So these are snapshots of the most interesting part. You'll have probably a hard time finding this. We are preparing a more elaborate publication about the birth of cybernetics and artificial intelligence in the Eastern Bloc, which has translations of both the papers from the Russians, which had a number of interesting papers at the time when cybernetics was frowned upon. So people still try to say how cybernetics is interesting. And those papers are actually not translated in English, and they're only available in Russian. Me and my PhD students were doing a bit of work on it and translating it. And we have several papers translated in Croatian, and also we'll make a reprint of Laszlo's paper. And you can see some parts of Laszlo's paper which are quite interesting. You have bits. There you have entropy at one point, or is it not here? It's on the next one. But the interesting part is that you had not only Laszlo here, you had a number of people. You had, at the Faculty of Philosophy, you had Laszlo from the Department of Slavistics. These were all teaching assistants back then. They were quite young. Svetozar Petrovic, Department of Literature. Stjepan Babić, Department of Croatology. Krunoslav Pranjic, Željko Bujas, Department of English. Malik Mulic, Department of Russian Language and Literature. From the Faculty of Electrotechnics, back then it was only Electrotechnics, now it's Electrotechnics and Computing. You had Vladimir Matkovic. He's perhaps the first one to research any of these subjects. In his PhD thesis from 1957, he calculated the cross-entropy of Croatian language, which is interesting because you can actually calculate cross-entropy of a language as a measurement of its efficiency. And you had Vladimir Muljevic from the Institute of System Control and Signals. You know that this is mainly something that was cybernetics without calling it cybernetics. So you had that part of the Soviet tradition alive and well. And from the Yugoslav Academy of Sciences and Arts, you had Božidar Finka. Perhaps you know of him from the Pravopis, the orthography creation, but people do not know that he was part of this circle, and Vladimir Vranic. As you see, you have 10 people doing research on this. It was a research group, a real research group with a number of people comparable to those in the US, comparable to those in the Soviet Union. The only problem is that they did not have a computer. And why they did not have a computer? Because Laszlo, if anyone had the privilege to know him personally, he was a really hard personality who was very insistent on Croatian peculiarities, and back then he wrote for financing in Belgrade, and in that two-page request for financing, he had to say and write a large footnote underlying the differences between Croatian and Serbian. So of course he didn't get the financing. So in 1959, if you wanted to be sure not getting any financing, do something like Laszlo did. But nevertheless, the ideas were interesting. So let us go through a couple of ideas here. So I can assume that you're familiar with today's ideas. So what do you say about this? Separate language encoding, word embeddings, and a separate translation algorithm. Positional encoding, key value processing for queries. Context, defined as the previous next word to make a representation of a word. Not the word as such, but its context makes the representation. The word is defined by its context. Translation that can be viewed as a predict next task. So when I say something in French, and the model simply has to predict what follows. And what follows should be, I don't know, the translation in Croatian. Or it can be seen as question answering. So the original text can be seen as a question, and what the machine should produce should be seen as an answer, the translation. Tokens that are neither words nor characters, but parts of words. As if you use tick token for calculating costs for ChatGPT or for anything else from OpenAI, then you'll probably know that this is something that is quite recent. Separate models based on cross-entropy to build internal representations for decoding and the other for the one for encoding and one decoding. Okay, so both the encoder and decoder could, in theory, be powerful enough to be used without the other. Does this sound about right? Let's say GPT, BERT, T5, stuff like that. Except this is neither of that. These were ideas from Laszlo's 1959 paper, taken out of the paper. Something that we don't know. We say that artificial intelligence in Croatia started in 2006 with Yerbis's research group, and this is good. This is an excellent research group, and they have excellent results. But the start was here. So, thank you for your attention, and questions are welcome. You're all convinced that this is well done. Let us all go to the Faculty of Computing and simply spread the gospel. Okay.
Sandro, thank you very much.
Thank you.